Hello. In this video, we're going to look at graphing polynomial functions. Now, let's say we have a polynomial like 1/2 3x plus 1, x minus 1, and x plus 2 squared. How would we make a graph for a function like this? The basic idea is we're going to do the reverse process of what we did before. Before we were given a graph and we were asked to find the polynomial, and now we are given a polynomial and we're asked to find the graph. And the thing that connects both of them, the key idea, is the x-intercepts. If you look at each one of these factors, 3x plus 1, or x minus 1, or x plus 2, each one of those factors is going to give us an x-intercept. In the first case, we're going to get x equals -1/3. The second one is going to give us x equals 1, and the third one is going to give us x equals -2. And all three of those are going to be nice points that we can plot on the graph. So we've got one here at 1, one at -2, and one at -1/3. And it's a good idea to label your points if your graph is just an xy axis without any tick marks on it. Now, we're also going to need the y-intercept, and that's not given initially by the function, but you can calculate it pretty easily. The y-intercept is going to be when x is equal to 0, so you calculate f of 0. Well, that's just going to be equal to 1/2. 3 times 0 is 0 plus 1, and then 0 minus 1 is -1, 0 plus 2 is 2, and we have to square it. So we get 1/2 times -1 times 4, so that's going to be -4/2, -2. So down here we have the y-intercept at -2. Now the last thing we need is any kind of bounce or cross through. If you look here, this is degree 2. So we know that at x equals -2, it's going to bounce. And it's either going to bounce going up or it's going to bounce going down. And we're not quite sure exactly which one is going to be, if it's either bouncing up or bouncing down. But basically, we can just try to draw the graph and see what happens. If we try bouncing underneath, then we cross through here. Well, that's not where the y-intercept is. The y-intercept is negative. So let's guess and check the other way. Let's say it bounces this way. And we connect all of our dots and, well, there we go. We're good to go. We've crossed through each x-intercept. We've crossed through the y-intercept. And importantly, we've made sure that we bounce at the intercept that comes from degree 2. Now, there are some other features, of course, on this graph. You might notice that there's a bit of a hill here. But the hill isn't relevant. We need calculus actually to find the value of that hill. And so as long as you connect your dots in a nice smooth motion, you'll have a polynomial and your graph will be good enough. All right, so let's go ahead and try this one. I encourage you to pause the video and give it a try. At least come up with the x-intercepts and the y-intercept and see if you can give the graph a rough sketch. All right, here we go. We have x equal to 2, x equal to -1, and x equal to -2. Now notice, we can plot those intercepts as 2, -2, and -1. And they're each going to be a different style. The first one at -1 there, that's just going to be a cross right through. The one with degree 2 is going to bounce, and the one with degree 3 is going to cross through, but it kind of slides along or flattens out. Now let's also find the y-intercept. So we calculate f of 0. That'll be 1/4 -2 squared, 1, 2 cubed. So we get 1/4 times 4 times 2 cubed, so that'll be 8. And that gives us just a y-intercept at 8. So we put that on the graph. Again, don't worry too much about the scale. Now let's go ahead and sketch the graph. We know that it's got a bounce at the 2. And so if we imagine it bouncing underneath, well, it would have to go back up to this y-intercept. And we can't really have that happen because that would introduce an extra x-intercept here. And we know there's only 3 intercepts. There's no x-intercept over there. Or if we tried to have it bounce, it would go through down here before it comes back up, and there's no y-intercept in the negative. So just through a little bit of logical reasoning, we can tell that the bounce has to happen up. It's got to be bouncing like this. So we've got most of the graph here. We've bounced, gone through the y-intercept. We've cut through at -1. Now remember though, when we go through that intercept at -2, we can't just cross through like this. If we do this, we won't get full marks because this looks like a degree 1 intercept. Instead, when we go through the -2, we have to flatten out and then keep on going, so that it looks here like a degree 3 intercept. It's very important that we have that kind of flattening out or it's sliding along. Again, that looks different here from, say, a degree 1, where it just simply crosses through the x-axis. All right, we have another one here. Go ahead and pause the video and give this a try. All right, this one's got a bit of a trick to it. If you look here, the x plus 1 shows up twice, which means we should be writing this as x plus 1 squared. So the intercept, x equals -1, that x-intercept is actually going to be a bounce, a degree 2 intercept. Now we also have one at x equals 2. That's going to be a bounce as well. And believe it or not, this x in front, even though it's not in brackets, it's also an x-intercept, x equal to 0. Let's go ahead and graph all three of these. We have the one at 0. We have the one at -1. And we have the one at 2. Now, we need to find the y-intercept, but when we do that, we notice that the first term gives you 0. -2 times 0 is 0, and then anything times 0 will be 0. So the y-intercept is also an x-intercept, and this is a little bit problematic. To graph this function, we need a y-intercept because it kind of acts as our checkpoint to figure out, is it going to be bouncing up or is it going to be bouncing down? How do I connect these dots? And if you look here, without the y-intercept, or with the y-intercept just being an x-intercept, really anything is possible. We could have it bouncing here, going through, and then bouncing down, and that would be totally fine. Or we could have it bouncing underneath, going through, and then bouncing up. And there's no way to tell which graph is correct. So we need another point. I'm going to say maybe something like at 1. Maybe we'll try x equals 1, just to help us figure out between these two graphs which is which. And so we plug in x equal to 1. So I get -2 times 1, 1 plus 1. Well, actually, that's 1 plus 1 squared. Make that a little easier. 1 minus 2 squared. So that gives -2 times 2 squared times -1 squared. So that's going to give me -2 times 4 times 1, or -8. So I know down here, I'm going to have a point at 1 and -8. Now that's going to really help me, because if I try to bounce up here, well, I'm never going to make it down to the point at 1 and -8. So I know I have to be bouncing down here. Now, of course, I have to go back and cross through that x-intercept at x equals 0. Then I have to bounce again, and I'm good to go. Again, some of these graphs might look a little bit different on Desmos depending on the scale. So if you pull this up on Desmos and you get a slightly different looking graph, don't worry about it too much. You can kind of pinch and zoom around. The main thing we're looking for here is the overall shape. As long as the intercepts are correct and the bouncing behavior is correct, the precise details on the rest of the graph aren't that important. The overall shape is what matters. Let's go ahead and do one more, and in this case, I'm going to give you the polynomial, but if you notice, it's not been factored. So we have the zeros are 1, 2, and -3. We have the original polynomial, and you're asked to sketch the function. So there's a bit of a twist here. Go ahead and pause the video and see if you can come up with the solution. All right. The trick here is that because I haven't factored it, we might know that there's intercepts at 1 and at 2 and at -3. But we don't know if any of them are going to be bounce intercepts. In fact, if we look at the polynomial, it's degree 4. That means we would expect there to be 4 factors. And since we only have 3 intercepts, Well, to get to 4, one of them has to be a repeated intercept. It has to be double. It has to have a 2 on the power of it. So we're going to have to use our skill of synthetic division. We're going to have to factor this down. Now, before you say, oh no, there's going to be so many possible options for factoring. I mean, look at that 18. All the factors of 18, plus minus 1, 2, 3, 6. There's so many options. You actually don't have to try a bunch of options. You've been given the factors right here. The zeros are the factors. So we can start with the easiest one, 1. And we'll get 1. 1 times 1 is 1. 4, 4, negative 3, negative 3, negative 18, negative 18, and 0. It works out, and of course it works out, because the x-intercepts are the zeros. They're the numbers that make the function equal to 0. Now let's do the next one. Let's do 2. Well, we have 1. 1 times 2 is 2. 6, 12, 9, 18, and 0. And finally, let's do negative 3. 1, negative 3, 3, negative 9, and 0. If you notice, I'm stacking my synthetic division just to save some space. So this means we're going to have an x minus 1 from the first here, an x minus 2, and an x plus 3. And then we still have this term right here, which is x plus 3. We want to go ahead and combine these two. So that's going to give us x minus 1, x minus 2, and x plus 3 squared. Aha, we found it. This is going to be our bounce intercept. So we know we're going to be bouncing off of x minus 3. The last thing is to find the y-intercept. Now, I already know the y-intercept is 18. Just as a little trick here, when we plug in 0, we can plug it into the original polynomial, and that means the term with the x is gone, the x to the 4, x to the 3, x to the 2, and x. Because x is 0, all those terms disappear. So you end up with just 0 plus 0 minus 0 minus 0 plus 18. And so the y-intercept is 18. Now we can clearly see that we have to bounce off the first intercept. That way we can make it all the way up to the 18. So let's do that nicely. Bounce off the first intercept. Cross through the second, cross through the third. Throw some arrows, and we're good to go. Alright, hopefully you enjoyed this video. Thanks for watching.